Monte Carlo Tree Search method for selecting most promising next game states. Problem. You may perform random estimation of game results, 1 for winning or 0 for losing, by repeatedly choosing one of next states randomly until you reach end states. This operation is called playout. Assume you perform 6 times of playouts and each state has 3 next states except end states. Which next state will be most promising for the game's start state S0? One incorrect answer is as follows. State S0 has 3 next states S1, S2, and S3. You perform 2 times of playouts from each state. You pick up one state of highest average score. Average scores of 2 times may not be sufficient. Our correct answer is as follows. You create 3 next states from state S0. Starting from S0, you repeatedly select next state of maximum UCV score, given below, until you reach the terminal state T having no next states. If T has no playout yet, perform playout, update UCV scores, and repeat from step 1. If T has playout already, create 3 next states of T, perform playout from one of next states, update UCV scores, and repeat from step 1. Definition of UCV score. Here, MJ stands for the average score of state SJ when SJ was used. NJ stands for the number of playouts in the subtree of SJ. N stands for the number of playouts in SJ's parent state's subtree. NN stands for natural log function. UCV score. General UCV score has the balancing constant. The first term of UCV score gets bigger when state SJ's average score is very good. This part is for exploitation of good states. The second term of UCV score gets smaller when state SJ is tried many times. This part is for exploration of less used states. Here is one example with average scores and UCV scores. We create states S1, S2, and S3. We select S1, playout, and update UCV scores. We select S2, playout, and update UCV scores. We select S3, playout, and update UCV scores. We select S3. We create states S4, S5, and S6. We select S4, playout, and update UCV scores. We select S5, playout, and update UCV scores. We select S1, we create states S7, S8, and S9. We select S7, playout, and update UCV scores. Our computation is over. We choose S3 as the most promising next state of S0 because of highest average score. Conclusion. This method is called UCT method used in Monte Carlo Tree Search UCT stands for Upper Confidence Bounds Applied to Trees. This method allows us to select most promising next game states in Othello and Go without using special domain knowledge.